Let me open our sessions. Move to my talk. My research focused on non-prompt lepton discrimination study with BDT in CTH, Multilepton Final State at ATLAS Detector. I worked together with collaboration with Yuri Chinkapur, Austin of Texas University, and here, first slide. Our research was going in CERN, in ATLAS project. Next slide, please. Few words about physics motivations. I worked in the Higgs group. In ATLAS projects has one big Higgs groups. Is divided to 8 physics subgroups, and one of these subgroups is each top, and one of channel of these subgroups is CTH, multilepton groups. And our physical motivations that is CTH measuring directly the top equal coupling, and which are considered proportional to the top quartz mark, for example, for all fermions quartz, in our case in top quartz marks. And as you know, have two major decay, each Higgs decay, each Higgs BB, it's dominate decay, but this decay has a irreducible background with TT bar plus BB. So we're working in decay in each to WW in second largest Bayesian ratio. And from theoretical evaluation, for the cross section TTH at 8 TV, we have 130 femtobar and expect 270 events. And TTH events with, as you know, round 1 has 21 reverse femtobar. And do you hear us on this internet? My smiling?
Yes, I
hello? Do you hear?
Yes, I am here.
Okay. On the left side, on the slide, you can see the payment diagrams is the production Higgs boson associated with top quark, top anti-top quarks. And we have for TTH 588 events for TTH with 4W plus 2B, the TTH 2W 2 tau plus 2B 172 events, and for TTH 2W 2Z plus 2B it's 72 events. It's all theoretical predict what if have do before run 1. Next slide, please. So we have in TTH 5 channel, each VB. Higgs to decay to WW, tau, and ZZ. And it's TTH to same sign leptons, it's TTH to 3 leptons, it's TTH 4 leptons, and TTH 2 lepton plus 1 tau, and TTH 1 lepton plus 2 tau. As right on the side, you can see same diagram where you have TTH for 3 lepton. As you see, can one first top decay to W and P, Higgs to W, and stop decay to B, W boson and B. So as a final state, we have 1, 2, 3 leptons and 1 neutrino, big quark, 2 big quark, and several neutrino. Next slide, please. So about few words about the background. For example, on the table you can see all channel. For example, if same signs, it's meaning 2 lepton, electron plus 5 jets. 2 lepton, electron muon, it's opposite sides, 5 G plus 5 jet, 2 lepton muon 5 jet, 2 electron plus 4 jets, and 3 lepton working in this decay and in this mode. As you can see from the 4 columns, its background from top, its background for TTW, its background from T, TZ, and VV, and Z was Z in percent. And if we shift to this line, to this row, you can see we have a 11.6%, have a from all the ground down from the CT bar. Next slide, please. So now we move to our idea. Our idea is use MVA. MVA is multivariate analysis and boost decision tree to separate prompt from leptons. What is mean prompt and no prompt lepton? If this lepton comes from Higgs, it's prompt lepton. If this lepton comes from BGX, its meaning is not from lepton. So for separate background Fock signal, we use this in multivariate analysis. Next slide, please. Strategy of research. We study round one. First, our step is matching procedure mark lepton as prompt and no prompt based of truth information in non-tachyral data. And last step, employ DVT for separate from non-prompt leptons. We use this sample from full simulation sample. This sample after reconstructions, but this sample has full truth information, which gives to us possibility to use prompt and mark lepton as prompt or not non-prompt lepton. Next slide, please. Our preselections. It's muon cuts matching with. Sorry. Muon cuts. I think it's working. Okay. Muon cuts. For muon cuts, we're using matching delta 0.05, eta 2.47. Muon, we use tight muons. For electron cuts, is matching delta 0.1, eta 2.47, and we use cuts very tight electrical heights for electrons. Next slide, please. Few words about the push decision tree. In input variables, we use next 6 variables: PT, eta, sin D0, Z0, ET-con divide PT, PT-con divide PT. BDT parameter is using ADA-boost algorithm, and depth equals C, and trees 200 trees. I tried to pass some technical details. I think you don't understand what I talk about. Okay, it's okay. Next slide, please. Next slide. I passed several slides because I have no time. Next. Переключайтесь, как это останется. Окей. Следующий слайд. Еще один слайд. Okay. So, we use some algorithm, some tool is name of scikit-learn. Scikit-learn, we use algorithm BDT plus decision tree. And what we done? We compare our result from BDT and result from standard cuts. For example, these points come with standard cuts. These points will come from standard cuts. And this zoom side on the top of the slide, we can see 2 plots, and the bottom of the slide is same plot, but in the zoom. Just you can see this point at our line. So it's our line rough curve. If you take this efficiency on the axis side, you can signal efficiency. If you can side, you can see background rejection. So if you take same efficiency, for example, as we receive after the apply standard cut, you can see our rough curve has more back rejection, and we can use this rough curve, for example, reduce background. Next slide, please. Sorry. Next slide, please. Okay. It's same zoom for it's same plots, and the past slide in just one plot and in zoom. You can see clear here points after the standard cuts and our rough curve. And you can see from this, from same efficiency, we have a we have a big background rejection. Okay, next slide. Same slide for muons. I don't repeat. It was for electron. Same slide for muon. Next slide. Same slide for muon in zoom side, and you can see point for after standard cut and our curve. Next slide. On this slide, we made validation, and we take 50 curve and show that all curve doesn't matter about samples in the random sum. In the random still, we have an identical curve, and all curve from our n sample give a better result than a result after standard cuts, after red points on the slide. Next slide. Next slide. Next. And it's very important result, and our result at present time. As you know, this is called the stable, it's Cutflow. And the left side of the slide, we can see Cutflow after apply standard selection cut. And you can see this first figure 6.10 for TTH. It means it's for signal, and 45.38 for TTH. But it's not for background. It's 2 points to figure we're getting after applying standard selection cut. When we apply our BDT, we receive next figure is 6.16. It's meaning we have 10% increasing of signal, and for TT bar 26.74. It's meaning closer to 15% reduce of background. Is meaning for us results, because this result shows that our methods is working, and we can increase signal and reduce background. And our summary, next slide. Summary, just use BDT for lepton instant rectangular cuts. It means standard selection cuts. Cutflow results show 15% less than TT bar and 10% for TTH, and compare the standard selection cut. And our plans repeat all this research for round 2. Apply scikit-learn and our BDT for round 2. In case of our improvement, propose to use BDT as of a main lepton selection method. Next slide. Next. It's our in our article as a red line. I show that after NZ one of the after of the ATLAS project. In this one, the after of this concrete this article. And next slide. Thank you for your patience. Do you have an equation from internet? Do you have a question? Any?
Nazim.
Mr. Suleymanov? Yes.
I have one question. What does it mean from lepton? How you can separate from lepton?
I talked about at the beginning of our talk. Second slide, 5 slides.
Because as we know, heavy particles, we understand what does it mean from.
Okay.
But for lepton,
okay, I give you an okay. I give you answer. We have a sample which has a after reconstruction. We have a this. Okay. What's this slide? Next slide. What? Slide 6. You can see sample full simulation sample. This sample has data after reconstructions and information about full truth. That's meaning we know which lepton prompt and which not prompt.
My question is simple. What a PT? What a PT for prompt?
What is meaning prompt, non-prompt? Or
what a PT? What a transfer momentum?
Mas transfer momentum is larger than 10 GeV. PT larger than 10 GeV.
Okay, I understand. Thank you.
Okay. Welcome.
Any other questions, please? And from online connection or from audience? No question, okay?
Thank you very much.
Thank you very much. Okay, and let's thanks to Dr. Nazim Huseynov from JINR for his good talk. Okay, thank you very much. Really, but the main importance, as I understand correctly, to reduce background and to increase the signal level